Good morning. Lesson 7-2, write equations to represent relationships. So before, in the previous lesson, we were given the rule, and then either given the input or the output, we could find the other one. But in this case, they're going to make us find the rule, and the rule is really a relationship between the numbers. How do the two numbers interact? I'm going to give you some good hints here. I would suggest following them. We'll see how it goes. Luciana earns $8 per hour walking dogs in her neighborhood. The table shows a relationship between the number of hours H she walks and the total amount D in dollars she earns. To write an equation that relates to variables H and D, first determine the rule that describes the relationship. So here's what I would tell you. This is really, because you're going to be graphing this later, your independent is your X and your dependent is your Y on your coordinate planes, remember? Y and X, remember that? Okay, this is your X. If these go up by 1, we're in good shape to be able to use these numbers, okay? So first you check, do these go up by 1? Yes. Then how much do these go up by? There probably is a pattern. 8 plus 8 is 16, 16 plus 8 is 24, 24 plus 8 is 32. So these are plus 8, which means we're going to have 8 times H. And then we test it and see if there's a difference. 1 in for H. What's 8 times 1? 8. 2 in for H. What's 8 times 2? 16. Then this is our rule. 8 times H, or in this case 1, 8 times 2, 8 times 3, and 8 times 4. So this was an easy one. Again, does your input column go up by 1? Yes. Then how much do these go up by? 8. Then you take 8 times that variable, and that is your rule. But you know, they're going to get harder, so let's do that. Ooh, let's try this one. Oh, goodness, these numbers. The table shows the total cost C of belonging to a gym for M number of months. Write an equation to represent the relationship between C and M. Okay, so does the independent variable go up by 1? Yes. Then how much do these go up by? Well, take 49.9 and subtract 24.95. It looks like they go up by 24.95. Okay, so let's check the other one. Plus 49.9. 74.85, it also goes up by 24.95. So this rule, let's try it. M, because these are labeled M, 24.95 M should equal C. So let's try it for the 5. 5 times 24.95 is 124.75. Boom, our rule works. That's how you write the rule. Now, let's get into a more complicated rule because that sounds more fun. Let's go over here to page 412. Actually, we're not quite ready for that one. Let's go to page 410. The table shows the total fees F for D days of library books is overdue. So 1 day overdue, you pay 30 cents. 2 days overdue, 50 cents. You'd think for 2 days it would be twice that, but it isn't. So there must be something different here. Write a 2-step equation. So we have been writing 1 steps. Now we're going to write 2-step. But it's really pretty similar. Does your input column go up by 1? Yes. Then how much does your output column go up by? 20 cents. So F equals, because this is F, 0.2 times D. And then let's test it. What's 0.2 times 1? Well, it's 0.2. Oh, this isn't 0.2. This is 30. So that means we added 10 cents. Let's try it over here. 2 times 0.2 is 0.40. Oh, no. 0.40 to get to 0.50 would be adding 10 cents. So this adding to get from where we multiplied to our answer, we put right here. And that's your rule. That's why we tested it earlier to see if it worked. Now let's test this one just to be sure. 4 times 0.2, and then we add 10 cents. Oh, 90 cents. Okay, this rule works. Now, let's get it just a little more complicated here. Days, land, and Bailey. So we're going to have to write more than one rule. The table shows the total number of miles Lan and Bailey have run over a certain number of days. So for 2 days, one guy ran 8, one guy ran 6. If the pattern continues, how many more miles will Bailey have run after 6 days than Lan? So we could just extend this out to 6 days, but later, what if they ask us after 30 days? Do you want to write this chart out for 30 days? Sames, me neither. So we're actually going to write 2 rules. We're going to write a rule to get from days to Lan, and we're going to write a rule to get from days to Bailey. Then we can substitute the value of the variable. So I'm going to say this is D, L, and B, and we'll write some rules. So as these go up by 1, what does Lan go up by? He goes up by 2. So Lan is equal to 2 times the number of days. Let's test it. 1 times 2 is 2. Oh, that's not 2. Well, how do I get from 2 to 6? Add 4. Okay, let's try it here. 2 times 2 is 4. How do I get from 4 to 8? Add 4. So as those start to repeat, we can determine that that's the rule. So this is the rule for Lan. Let's do the same for Bailey. Again, these go up by 1. What do these go up by? Yeah, 3. Bailey equals 3 times D, and then let's test it. 1 times 3 is 3. Oh, and that's just the number. 2 times 3 is 6. Don't have to add anything. 3 times 3 is 9. Don't have to add anything. So Bailey's rule is a one-step equation. Now we can get back to the question. After 6 days, so where there's a D, we'll put in a 6. 2 times 6 plus 4. And then for Bailey, same idea. Bailey is going to equal 3 times 6. Well, 3 times 6 is 18. 2 times 6 is 12, and 12 plus 4 is 16. Okay? How many more miles will Bailey have run after 6 days than Lan? Well, how many more is Bailey than Lan? 2. 18 minus 16 equals 2. 2 miles more. That's our answer. Okay, that's 7-2. You'll notice things get a little more complicated as they build on each other. See you in the next lesson.